Okay, so hello and welcome everyone. Here is a bundling example. So this is a situation where we have two distinct goods that we could sell either separately with two prices, or we could sell them together as a bundle for a single price. We have two customers, we have known reservation prices for good A and good B, and true or false, we'd rather sell them as a bundle or separate instead of separately. Okay, so our valuation, our maximal willingness to pay for good A for consumer 1 is 100, and for consumer type B or type 2, it's 80. And for good B, our consumer type 1 will pay $20 and our consumer type B will pay $60. So the first thing you recognize is we definitely have negatively correlated preferences. One of them likes one good better and one of them likes the other good better. And that is a necessary precondition for bundling to be beneficial. Okay, so let's actually check and see what happens if they price them separately or together. So if they price them separately, we have two things to decide. Would we rather sell at the maximal willingness to pay, sell one of the good to one consumer and one of the good to the other consumer, or we would rather sell at the minimal willingness to pay such that we can sell both goods to both consumers? So let's go ahead and investigate. Suppose we sell them separately and we set a price of 80 for good A, then both type 1 and type 2 consumers will buy, and a price of 20 for good B, then both type 1 and type 2 consumers will buy. If so, our profits are 160. And I've circled that in red, that's what we want to do. Or boxed it in red, that's what we want to do. Alternatively, we could set a price of 100 for good A, and we could set a price of 60 for good B. However, if we do this, our profits are only going to be 150, right? So 90 plus 50, actually this should be 140, right? So 90 and 50, yeah, so it should be 140. Anyway, it's less than 160. The other thing that you'd want to check is you'd see what if we want to sell one good to both and then one good to just one. So for instance, maybe we want to set the price of good A at 100 and we want to set the price of good B at 20. And then would that be good? No, we get 90 plus 20, which is going to be less than this 160. Okay, so you'd want to verify that as well, I guess, at least in principle. What about the bundle? So if we want to sell the bundle, sell a single price for both goods, we could set the bundle price of 140 and then sell both goods to type 2 only. Or we could set the bundle price of 120 and then we could sell both goods to both consumers. And that's what we want to do. So if the bundle price is 120, our marginal cost to sell the bundle, right, would be 10 for each good. So marginal cost of the bundle would be 20. So 120 is the price of the bundle minus the marginal cost of the bundle is 20. Gives us 100 times 2 or 200, right? So it is better to sell the bundle because our profits are 200 instead of maximal profits of 160. So in this case, let's see, it was true or false. It is equally profitable. The answer would be false. It's not equally profitable. It's more profitable to sell as a bundle. Right, it's more profitable to sell at a bundle. Where did I get these prices from? I didn't put this in the table, but you could see just adding across, right? If type 1 is willing to pay 100 for good A and 20 for good B, they would pay 120 for both jointly. And if type 2 would pay 80 for good A and 60 for good B, they'd pay 140 for the two jointly.